What is state drift in Terraform?
State drift occurs when the real-world infrastructure differs from what is recorded in the Terraform state file, typically caused by manual changes made through cloud consoles, CLI tools, or other automation outside Terraform. Running Terraform plan detects drift by comparing the current state of resources via provider IPIs against the last known state. You can reconcile drift by running Terraform apply to enforce the desired configuration, or by updating the configuration to match intentional manual changes and running Terraform refresh only to update state without making infrastructure changes.
What is Terraform plan refresh only?
The refresh only flag on Terraform plan and apply creates a plan that only updates the state file to match the current real-world state of resources, without proposing any configuration-driven changes. This is valuable for importing drift discovered by out-of-band changes that you want to acknowledge rather than revert. It effectively performs the refresh phase of a normal plan and shows you what has changed externally. Running Terraform, apply refresh-only updates state to reflect those external changes without modifying infrastructure.
How do you move a resource between Terraform state files?
Moving a resource between state files requires removing it from the source state and adding it to the destination state. You run Terraform state rm on the source to remove the resource without destroying it. Then run Terraform import in the destination configuration to bring the existing resource under management. The modern approach uses a combination of moved blocks within a configuration refactor. For large-scale migrations, Terraform state pull and push can manipulate the raw state JSON, but this is risky and requires careful state version management and locking.
What is Terraform state MV?
Terraform state MV moves a resource or module from one address to another within the same state file. It is used when you rename a resource in configuration, restructure configuration into or out of modules, or change count to for each on a resource. Without state MV, Terraform would plan to destroy the resource at the old address and create a new one at the new address, causing unnecessary disruption. The moved block in configuration is the preferred declarative alternative to Terraform state MV for most refactoring scenarios, as it can be reviewed and version controlled.
What is Terraform state RM?
Terraform state RM removes one or more resources from the Terraform state file without destroying the actual infrastructure. It is used when you want Terraform to stop managing a resource. For example, when taking over a resource with a different Terraform configuration, deliberately orphaning resources during decommissioning, or recovering from state corruption. After running state RM, Terraform will no longer track or update the resource. You can run Terraform import later to bring it back under management in a differend configuration if needed.
What is partial backend configuration in Terraform?
Partial backend configuration allows you to specify some backend configuration in the backend block in code while providing the rest at Terraform init time using backend config flags or a separate configuration file. This is useful for keeping sensitive values like access keys out of version control, or for reusing the same Terraform configuration across multiple environments where backend parameters differ, such as different S3 buckets or workspace names. The partial configuration must include at least the backend type. All other parameters can be supplied externally.
What is the S3 backend configuration for Terraform?
The S3 backend stores state in an Amazon S3 bucket. Key configuration parameters include bucket, key, the path within the bucket, and region. Enabling server-side encryption with encrypt equals true secures the state at rest. The DynamoDB table parameter specifies a DynamoDB table for state locking and consistency checking. The table must have a partition key named lock ID of type string. Versioning should be enabled on the S3 bucket to protect against accidental state deletion. IAM permissions must allow the required S3 and DynamoDB operations for Terraform to function.
What is Terraform Cloud?
Terraform Cloud is HashiCorp's managed service for Terraform that provides remote state storage, remote plan and apply execution, a private module registry, policy enforcement with Sentinel, team and access management, cost estimation, audit logging, and integrations with version control systems. It enables collaborative Terraform workflows where plans are triggered by code changes, reviewed via pull request integration, and applied in a governed manner. Terraform Cloud also provides workspaces, variable management, and run history. It is available as a free tier and paid plans with advanced features.
What is the difference between CLI workspaces and Terraform Cloud workspaces?
CLI workspaces are a feature of local and remote backends that create multiple state files from a single configuration, sharing all variables and configuration. They are accessed with the Terraform workspace commands. Terraform Cloud workspaces are independent working directories that each have their own configuration, variables, state, team permissions, and execution environment. Terraform Cloud workspaces are much more powerful and isolated, functioning more like separate Terraform projects. CLI workspaces are limited and generally not recommended for managing different environments. Separate configurations or Terraform Cloud workspaces are preferred.
What is remote execution in Terraform Cloud?
Remote execution runs Terraform plan and apply on Terraform Cloud's infrastructure rather than on a local machine or CI server. This provides a consistent execution environment, keeps credentials on cloud rather than local machines, maintains a complete history of runs with logs and state snapshots, and triggers runs from version control system webhooks. Plans can be reviewed and approved before applying. Remote execution also enables policy checks with Sentinel to run automatically as part of the plan and apply pipeline before operators approve changes.
What are variable sets in Terraform Cloud?
Variable sets in Terraform Cloud are collections of variables that can be applied to multiple workspaces simultaneously. Instead of entering the same credentials or configuration values in each workspace, you define them once in a variable set and assign it to the relevant workspaces. Variable sets can contain Terraform variables and environment variables. They are particularly useful for shared cloud credentials, common tags, or organization-wide configuration. Variable precedence follows a defined order, with workspace-specific variables overriding variable set values.
What is a private module registry in Terraform Cloud?
The private module registry in Terraform Cloud allows organizations to publish and share Terraform modules internally without making them publicly available on the Terraform registry. Modules are registered from version control repositories with semantic versioning based on Git tags. Internal users can browse the registry, view documentation generated from variables and outputs, and reference modules by their private registry source address. This enables a service catalog model where platform teams publish approved modules that application teams consume, ensuring organizational standards and best practices.
What is Sentinel in Terraform?
Sentinel is HashiCorp's policy as code framework integrated into Terraform Cloud and Enterprise. It allows organizations to define policies that are automatically enforced as part of every Terraform run, preventing infrastructure configurations that violate organizational standards. Sentinel policies are written in the Sentinel language and can access the Terraform plan, state, configuration, and run details. Policies can be enforced at different strictness levels: advisory, soft mandatory, and hard mandatory, giving operators flexibility in how strictly rules are enforced when exceptions are needed.
What are run tasks in Terraform Cloud?
Run tasks are integration points that allow external services to participate in the Terraform Cloud run lifecycle. They can run at different stages, before and after planning, and before and after applying, and can either provide information or block runs based on the result. Common use cases include security scanning with tools like Snike or Aqua, cost estimation, compliance checking, and custom validation logic. Run tasks call an HTTPS endpoint with plan data and receive a status response that determines whether the run proceeds or is blocked.
What are run triggers in Terraform Cloud?
Run triggers in Terraform Cloud create dependencies between workspaces so that when one workspace successfully completes an apply, it automatically triggers a new run in dependent workspaces. This enables multi-workspace pipelines where infrastructure changes cascade through dependent layers. For example, a network workspace changes trigger compute workspace updates, which then trigger application workspace deployments. Run triggers replace manual coordination between workspace operators and enable fully automated layered infrastructure pipelines in Terraform Cloud.
What is TerraGrunt?
TerraGrunt is an open-source wrapper for Terraform that simplifies working with multiple Terraform modules in a large infrastructure codebase. It provides DRY, don't repeat yourself, configuration through a hierarchical TerraGrunt HCL file structure, automatic backend configuration generation, module versioning, dependency management between modules with dependency blocks, and hooks for running commands before and after Terraform. TerraGrunt is particularly popular for managing large multi-account, multi-region AWS infrastructures, where the same modules are deployed to many environments with varying configurations.
What is Atlantis?
Atlantis is an open-source tool for Terraform pull request automation that runs Terraform plan on every pull request and comments the plan output back to the PR, enabling reviewers to see infrastructure changes without local access to credentials. It runs Terraform apply when a PR is approved and merged, providing a workflow where infrastructure changes require peer review. Atlantis can be configured with custom workflows, locking, policy enforcement hooks, and integration with GitHub, GitLab, and Bitbucket. It is self-hosted, giving teams full control over their automation without a SAW dependency.
What are dynamic blocks in Terraform?
Dynamic blocks allow you to generate repeated nested blocks within a resource, data source, or provider configuration based on a collection. They use a dynamic block wrapping the block type name, with a for each argument and a content block describing what to generate for each element. For example, a security group resource can generate multiple ingress blocks from a list of rules. Dynamic blocks are essential when the number of nested blocks is not known at design time and must be computed from variables or other resources. The iterator argument can rename the iteration variable from the default block type name.
What is the splat expression in Terraform?
A splat expression is a shorthand for extracting an attribute from all instances of a resource or all elements of a list. The legacy splat uses on a list before the attribute name, for example, Oz instance web. ID collects all instance ID tickets when count is used. The full splat expression traverses nested attributes. Splat expressions simplify collecting lists of ID tickets or other values from multiple resource instances to pass to another resource expecting a list, replacing verbose for expressions in simple projection scenarios.
What are provider aliases in Terraform?
Provider aliases allow you to create multiple configurations of the same provider within a single module, enabling multi-region or multi-account deployments. You define additional provider configurations with an alias argument in the provider block. Resources then reference a specific provider configuration using the provider meta-argument with the format provider name alias name. For example, two AWS provider blocks with different regions and aliases allow creating resources in multiple AWS regions from the same Terraform configuration. Child modules receive aliased providers through the provider's argument in the module block.
What is multi-region deployment with provider aliases?
Multi-region deployment uses aliased provider configurations to create infrastructure in multiple cloud regions from a single Terraform configuration. You define multiple provider blocks with different regions and unique alias values, then assign resources to specific provider configurations using the provider meta-argument. When calling modules, you pass the appropriate aliased provider via the provider's map in the module block. This pattern is used for global applications, disaster recovery configurations, and region-specific compliance requirements. It requires careful management as the dependency graph spans multiple provider configurations.
What is the target flag in Terraform?
The target flag limits a plan or apply operation to a specific resource or module, ignoring all other resources in the configuration. This is useful for iterative development, applying a subset of changes, or recovering from partial failures. For example, Terraform apply target equals AWS instance web applies only changes to that specific instance. However, target should be used sparingly in production, as it can create inconsistency between configuration and state when other resources have dependencies on the targeted ones. HashiCorp recommends using the full configuration apply in production workflows.
What is the replace flag in Terraform?
The replace flag forces Terraform to plan the destruction and recreation of a specific resource, even if its configuration has not changed. This is used to replace a resource that is in a degraded state, trigger reexecution of provisioners, or force adoption of a new resource ID from the provider. The syntax is Terraform apply replace equals resource address. It is the modern replacement for the deprecated Terraform taint command and has the advantage of showing the replacement in the plan output before any changes occur, enabling review and confirmation before execution.
What is the import block in Terraform 1.5+?
The import block, introduced in Terraform 1.5, allows you to declaratively import existing resources in your configuration file rather than using an imperative command. You add an import block with the ID of the existing resource and the to address in configuration, and include it in the normal plan and apply cycle. The import appears in the plan output as a new resource being imported, enabling review and approval like any other change. Multiple import blocks can import multiple resources in a single apply. Combined with generate configout, Terraform generates the corresponding resource configuration automatically.
What is generated configuration in Terraform?
Generated configuration, introduced in Terraform 1.5, is an experimental feature that automatically creates HCL resource blocks for resources being imported. When you run Terraform plan generate configout equals generated TF with import blocks defined, Terraform queries the provider for the current state of each imported resource and writes the corresponding resource configuration to the specified file. This dramatically reduces the manual work of writing configuration for existing resources and ensures the generated configuration matches the actual resource state. The generated configuration should be reviewed and cleaned up before committing.
What are preconditions and postconditions in Terraform?
Preconditions and postconditions are lifecycle validation blocks that add contract assertions to resources, data sources, and outputs. Preconditions run before the resource action and validate that the inputs meet required conditions, providing better error messages than the default provider validation. Postconditions run after the resource action and verify the result meets expectations. Both use a condition expression and error message. They make the assumptions and guarantees of a module explicit and machine-checked, improving module reliability and making failures understandable to module consumers.
What is replace-a-trigger-edby in the lifecycle block?
Replace-a-trigger-edby is a lifecycle meta-argument that specifies a list of references to resources, resource attributes, or other values that trigger the replacement of the containing resource when they change. This is useful when a resource depends on another in a way that requires full recreation. For example, an EC2 instance that needs to be replaced when its user data script changes, or when the IMI it depends on is updated. Unlike the depends-in meta-argument, which only controls ordering, replace-a-triggered by actively causes recreation on changes.
What is the try function in Terraform?
The try function evaluates a sequence of expressions and returns the result of the first one that does not produce an error. It is useful for gracefully handling optional or uncertain data structures, such as when a resource attribute might be null or when a map key might be absent. For example, try resource name. Attribute default returns the attribute value if it exists or the default string if accessing it would error. Try accepts any number of expressions and is commonly used to handle schema differences between provider versions or optional nested attributes in data sources.
What is the one function in Terraform?
The one function takes a list and returns either the single element if the list has one item or null if the list is empty. It errors if the list has more than one element. It is used to convert a list that is expected to contain at most one value into a single value or null, which is often needed when a resource attribute like count results in a list. For example, 1 osinstance web asterisk publicip returns either the single public IP or null when no instance was created, avoiding awkward index access.
What is the toSet function in Terraform?
The toSet function converts a list to a set, removing duplicate values and discarding ordering. Sets are required by the for-each meta-argument and certain resource arguments. toSet is used to convert a list variable to a set before using it with for-each to ensure each value appears exactly once. For example, for-each equals toSet var availability. Creates one resource instance per unique availability zone. Because sets are unordered, you should not rely on element order when iterating over sets with for each.
What is the contains function in Terraform?
The contains function checks whether a given value exists in a given list, set, or tuple, returning true if found and false otherwise. The syntax is contains list value. It is commonly used in precondition conditions and conditional expressions to validate that an input variable is one of a set of allowed values. For example, contains T3 micro, T3 small, M5 large, var instance type. It can also be used in for expression filters to select elements that satisfy membership in another collection.
What is the coalesce function in Terraform?
The coalesce function takes multiple arguments and returns the first non-null, non-empty value. It is useful for implementing fallback logic. For example, coalesce var custom name local generated name returns the custom name if provided, otherwise the generated one. Coalesce a list works similarly for lists, returning the first non-empty list from the arguments. These functions simplify optional variable patterns and reduce the need for nested conditional expressions when providing default fallback values.
What is an override file in Terraform?
Override files are special Terraform configuration files named override.tf, or any file ending in override TF. That merge their content on top of regular configuration files rather than being treated as additional files. When two files define the same resource or other block, the override file's definition wins. Override files are primarily used for testing, where you temporarily substitute mock providers or resource configurations. And for CI environments that need slightly different configurations without modifying the main files. They should not be used for regular configuration as they make behavior harder to understand.
What is the Terraform data resource?
The Terraform data resource is a built-in replacement for null resource that stores an arbitrary input value in state and uses a triggersReplace argument to control when it should be recreated. When triggersReplace changes, the Terraform data instance is destroyed and recreated, which reruns any attached provisioners. Unlike null resource, it does not require the HashiCorp/null provider. The input attribute stores a value that is preserved in state across runs, and output exposes that stored value. It is the idiomatic modern way to attach provisioners and track arbitrary values in Terraform state.
What is the removed block in Terraform?
The removed block, introduced in Terraform 1.7, is the declarative way to remove a resource from Terraform management in configuration while recording the intent in version-controlled code. Unlike running Terraform state RM imperatively, the removed block documents that the resource was intentionally decommissioned. It specifies the resource address and a destroy argument, where destroy equals true destroys the resource and destroy equals false removes it from state without destroying it. The removed block is processed during the next Terraform apply and then can be deleted from configuration.
What is drift detection in Terraform Cloud?
Drift detection in Terraform Cloud automatically runs Terraform plan on a schedule across workspaces to detect when real-world infrastructure has diverged from the Terraform state. When drift is detected, it notifies workspace operators via the Terraform Cloud UI and configured notifications so they can investigate and reconcile without waiting for a manual plan. This continuous validation ensures that out-of-band changes are caught quickly, maintaining the principle that Terraform is the authoritative source of truth for managed infrastructure.
What are Terraform Cloud agents?
Terraform Cloud agents are lightweight processes that run in your own network infrastructure and connect to Terraform Cloud to receive and execute plan and apply requests. They enable remote execution for infrastructure that is not accessible from Terraform Cloud's external network, such as resources in private networks, on-premises data centers, or behind strict firewalls. Agents are organized into agent pools, and workspaces are configured to use a specific pool. Agents connect outbound to Terraform Cloud and poll for work, requiring only outbound HTTPS access from your network.
What is OpenTofu?
OpenTofu is the open-source fork of Terraform created after HashiCorp changed Terraform's license from MPL 2.0 to the Business Source License, BSL, in August 2023. It is maintained by the Linux Foundation under the OpenTofu project and aims to be a fully compatible drop-in replacement for Terraform. OpenTofu has added features not present in Terraform, including state encryption, provider-defined functions, removed block, and others. Organizations that require a fully open-source IIC tool or want to avoid BSL license restrictions can use OpenTofu as an alternative.
What is CDK-TF, CDK for Terraform?
CDK for Terraform allows you to define Terraform infrastructure using familiar programming languages like TypeScript, Python, Java, C#, and Go instead of writing HCL directly. You write classes that synthesize into Terraform JSON configuration files, which are then applied using the Terraform CLI. CDKTF leverages the full power of programming languages for abstractions, loops, conditionals, and sharing, without requiring teams to learn HCL. It is particularly attractive for teams with strong software engineering backgrounds who want to apply software design patterns to infrastructure code.
What is Pulumi compared to Terraform?
Pulumi is an infrastructure as code tool that uses general-purpose programming languages rather than domain-specific languages. Like Terraform, it manages cloud infrastructure through provider APIs and maintains state. Key differences include that Pulumi uses real programming languages with full type safety, IDE completions, and testing frameworks built in. Terraform uses HCL, which is simpler for non-programmers but less expressive. Pulumi state is typically managed via Pulumi Cloud, while Terraform state can be managed anywhere. Both tools support similar cloud providers and have large communities.
What is Crossplane compared to Terraform?
Crossplane is a Kubernetes-based infrastructure control plane that manages cloud resources through Kubernetes custom resources rather than CLI-driven plans. Unlike Terraform, which is run as a workflow, Crossplane runs continuously in a Kubernetes cluster and continuously reconciles desired state with actual state, similar to how Kubernetes operators work. Crossplane is ideal for GitOps workflows driven by Kubernetes manifests and enables infrastructure provisioning as part of Kubernetes native application deployment. Terraform is better for standalone infrastructure management and has broader provider support.
What is OPA, Open Policy Agent, with Terraform?
OP is a general-purpose policy engine that can evaluate Terraform plan JSON output against policies written in the Rego language. Unlike Sentinel, which is HashiCorp-specific, OP integrates with CI/CD pipelines as an open-source tool. You run Terraform plan out equals plan TF plan, convert it to JSON with Terraform show JSON, then evaluate the JSON against OP policies using the OPA eval command. Tools like conftest provide a convenient wrapper for OPA-based Terraform policy evaluation. OP is commonly used in pipelines that cannot use Terraform Cloud's Sentinel feature.
What is TFSec?
TFSec is a static analysis tool for Terraform configurations that detects security misconfigurations and policy violations without running Terraform plan. It analyzes HCL files directly and checks for common security issues like public S3 buckets, unencrypted storage, open security groups, missing logging configuration, and IAM overpermissioning. TFSec has been superseded by Trivy by Aqua Security, which incorporates TFSec's rules along with broader infrastructure scanning capabilities. It integrates easily into CI pipelines as a fast pre-check before running Terraform commands.
What is Chekhov?
Chekhov is an open-source static code analysis tool for infrastructure as code that supports Terraform, CloudFormation, Kubernetes, Helm, and other formats. It scans Terraform configurations against hundreds of built-in security and compliance policies, covering CIS benchmarks, SOC2, PCIDSS, and other frameworks. Chekhov produces reports showing which checks passed, failed, or were skipped, and supports custom policies in Python or YAML. It integrates with CI pipelines, IDE plugins, and Terraform Cloud run tasks to provide policy as code enforcement throughout the IIC development lifecycle.
What is Infracost?
Infracost is an open-source tool that provides cloud cost estimation for Terraform configurations before applying them. It analyzes the Terraform plan and calculates the monthly cost impact of changes, showing which resources will be created, modified, or deleted along with their cost differentials. Infracost integrates with CI/CD pipelines and posts cost estimates as comments on pull requests, enabling developers to see the financial impact of infrastructure changes during code review. It supports AWS, Azure, and GCP, and connects to their pricing APIs to retrieve current rates.
What is the Terraform test command?
The Terraform test command, introduced in Terraform 1.6, runs automated tests defined in tf-test-HCL files to validate that modules behave correctly. Tests create real or mocked infrastructure resources, assert that outputs and resource attributes have expected values, and clean up afterward. The test framework supports run blocks that call modules, assert blocks that check conditions, and integration with mock providers to avoid creating real resources for unit-style tests. Terraform Test enables module developers to write comprehensive tests that validate module behavior before publishing.
What is a tf-test-HCL file?
A tf-test-HCL test file defines automated tests for a Terraform module. It contains provider blocks for configuring the providers used in tests, run blocks that invoke the module or configuration under test with specific variable values, and assert blocks within run blocks that check conditions on outputs and resource attributes. Multiple run blocks represent sequential test steps that can build on each other's state. Variables blocks provide input values, and the test framework supports both real infrastructure creation and mock provider substitution for faster, cheaper unit tests.
What are mock providers in Terraform tests?
Mock providers, available in the Terraform test framework, replace real provider implementations with simulated ones during tests. Instead of creating actual cloud resources, mock providers return computed or user-defined attribute values, allowing tests to run quickly without cloud credentials or infrastructure costs. Mock providers are configured in test files using mock provider blocks that override specific resource types. Module developers can test module logic, variable validation, output computation, and resource configuration, without incurring the time and cost of real resource creation.
What is the module composition pattern in Terraform?
Module composition is an architectural pattern where complex infrastructure is built from multiple small, focused modules that each do one thing well. A root module composes them by calling each child module and wiring outputs of one module to inputs of another. For example, a network module creates VPC and subnets, a security module creates security groups, a compute module creates EC2 instances using the network and security module outputs. This pattern improves reusability, testability, and separation of concerns, keeping each module small and maintainable rather than building one large monolithic module.
What is the workspace-based environment pattern in Terraform?
The workspace-based environment pattern uses CLI workspaces to manage multiple environments, dev, staging, production, from a single configuration. Each workspace has its own state, and the configuration uses the Terraform workspace value to vary resource names, sizes, or counts per environment. For example, a production workspace gets 3 replicas, while other workspaces get 1. While convenient for simple cases, this pattern has limitations. All environments share the same configuration and variables structure, making it hard to have fundamentally different configurations. And workspaces require manual workspace selection, which is error-prone in CI.
What is the directory-based environment pattern in Terraform?
The directory-based environment pattern gives each environment its own Terraform configuration directory, containing environment-specific configurations and TFVARS files, all sourcing shared modules. For example, environment/dev/, environment/staging/, and environment/production/ each have their own main TF backend, TF, and Terraform TFVARS. This provides strong isolation between environments, allows fundamentally different configurations per environment, and makes it clear where each environment's configuration lives. It requires some duplication, but is far more robust and explicit than the workspace-based pattern for complex environments.
What is a monorepo pattern for Terraform?
A monorepo pattern stores all Terraform configurations in a single source code repository, organized in directories by environment, account, region, or service. Team members work in the same repository, enabling cross-cutting changes and refactoring. The monorepo approach makes it easy to see all infrastructure in one place, share modules without a separate registry, and run CI across all configurations. Tools like TerraGrunt, Atlantis, and Custom CI scripts handle the complexity of determining which directories need to be planned and applied based on which files changed. This approach is popular in large organizations.
What is a polyrepo pattern for Terraform?
A polyrepo pattern stores each Terraform configuration or module in its own separate repository. This provides strong boundaries between teams and components, allows independent versioning and access control, and keeps each repository focused and small. Teams reference shared modules from other repositories using version-pinned Git sources or the private module registry. The polyrepo approach requires more repository management overhead and makes cross-cutting refactoring harder, but is preferred in organizations with clear team ownership boundaries and strict access control requirements.
What is OIDC dynamic credentials in Terraform Cloud?
OIDC, OpenID Connect. Dynamic credentials allow Terraform Cloud workspaces to assume cloud provider roles using short-lived tokens rather than storing long-lived access keys as static variables. Terraform Cloud acts as an OIDC identity provider, and you configure cloud providers to trust tokens from Terraform Cloud. During each run, Terraform Cloud generates a one-time token that is exchanged for temporary cloud credentials via the cloud provider's OIDC federation. This eliminates the security risk of storing and rotating static cloud credentials in Terraform Cloud workspaces, implementing a zero-standing privileges model for Terraform execution.
What is workload identity federation in Terraform Cloud?
Workload identity federation is the underlying mechanism behind OIDC dynamic credentials. Terraform Cloud presents assigned JWT OIDC token with claims identifying the workspace, organization, run phase, and other metadata. Cloud providers like AWS, Azure, and GCP can be configured to accept these tokens via their federation mechanisms. AWS IAM OIDC provider, Azure ID Workload Identity, or GCP Workload Identity Pool. The cloud provider validates the token and issues temporary credentials scoped to a specific IAM role or service account. This removes the need to manage any static credentials in Terraform Cloud.
What is cost estimation in Terraform Cloud?
Cost estimation in Terraform Cloud analyzes a Terraform plan and calculates the estimated monthly cost impact of the proposed infrastructure changes. It shows the cost of resources being created, modified, and destroyed, as well as the net cost delta. Cost estimates are displayed in the Terraform Cloud UI as part of every run and can be used in Sentinel policies to enforce cost budgets. For example, blocking applies that would increase monthly spend by more than a threshold. Cost estimation supports AWS, Azure, and GCP and covers the most common resource types.
What is a policy set in Terraform Cloud?
A policy set in Terraform Cloud is a collection of Sentinel or OPA policies that can be applied to one or more workspaces or entire organizations. Policy sets are sourced from version control repositories or uploaded directly. When a policy set is associated with workspaces, its policies are evaluated during every run. Policy sets can be applied globally to all workspaces in an organization, to all workspaces in specific projects, or to individually selected workspaces, providing granular policy enforcement. Version policy sets support the same Git ops workflows as configuration code.
What are Terraform run tasks, and how do they differ from Sentinel?
Run tasks are integration points that call external HTTPS endpoints at specific stages of a Terraform run and receive pass or fail responses. They are implemented by third-party tools and can check security, cost, compliance, or any custom logic. Sentinel is HashiCorp's built-in policy language that evaluates policies written in the Sentinel language against Terraform plan data natively within Terraform Cloud. Run tasks offer flexibility and third-party integrations, while Sentinel provides a powerful domain-specific language deeply integrated with Terraform plan data. Both can block or warn on policy violations.
What is the depends on argument in module blocks?
The depends on argument in a module block creates an explicit dependency from the calling module on specific external resources or modules. This is used when a module's resources depend on prerequisites that are not referenced within the module's configuration. For example, when a compute module needs certain IAM roles to exist before its resources are created, but the module does not directly reference those roles. Like depends on resources, it should be used sparingly because it disables Terraform's ability to parallelize all independent resources, potentially slowing execution significantly.
What is the provider's argument in module blocks?
The provider's argument in a module block explicitly maps provider configurations from the calling module to the expected providers within a child module. This is required when a child module uses aliased providers, or when you want to pass a specific provider configuration to a module rather than the default. For example, when calling a module for a secondary region, you pass the aliased provider for that region via providers equals us west 2. Without this, child modules inherit the default provider configurations from their caller, which may not be appropriate for multi-region or multi-account patterns.
What is the for each argument in module blocks?
The for each argument on module blocks creates multiple instances of the same module, each with different input values, using the same map or set syntax as resource for each. Each module instance gets its own isolated set of resources and state. Module instances are addressed as module name key. This pattern enables deploying the same infrastructure to multiple environments, regions, or accounts from a single module block. For example, for each equals var regions creates the module once per region, with per region variable values from the map.
What is Terraform FMT recursive?
The recursive flag on Terraform FMT formats all TF files in the current directory and all subdirectories. This is useful when you have a repository with multiple modules organized in subdirectories and want to ensure all code is consistently formatted in one command. Without recursive, only the TF files in the current directory are formatted. In CI pipelines, Terraform FMT recursive check verifies that all files in the repository are properly formatted and returns a non-zero exit code if any need reformatting, enforcing formatting standards across the entire codebase.
What is the Terraform provider's lock command?
Terraform providers lock records cryptographic checksums for provider packages in the dependency lock file for multiple platforms. By default, Terraform init only records checksums for the current platform. When working in teams with a mix of operating systems, Mac OS for development and Linux for CI, or when deploying Terraform in containers from a different OS, You run Terraform providers lock platform equals LinuxMD64 platform equals DarwinArm64 to record checksums for all required platforms. This ensures init can verify providers on all platforms using the same committed lock file without requiring a separate init per platform.
What is file system mirroring of Terraform providers?
File system mirroring allows you to serve providers from a local directory structure instead of downloading from the internet, using Terraform providers mirror to populate the mirror directory. Terraform then references the local mirror via the file system mirror configuration in the provider installation configuration. This is essential in air-gapped environments with no internet access, when internet connectivity is slow or restricted, or in enterprises that require all software to be sourced from internal artifact repositories. The mirror maintains the same directory structure expected by the Terraform plugin installation protocol.
What is a plugin cache in Terraform?
The Terraform plugin cache stores downloaded provider binaries in a shared local directory, so multiple Terraform configurations on the same machine share providers without downloading them repeatedly. You configure it by setting the plugin cachedir path in the Terraform CLI configuration file at ~terraformd/terraformrc or via the tf plugin cache dir environment variable. On CI systems where each pipeline run initializes Terraform from scratch, using a plugin cache backed by persistent storage significantly reduces init time and network usage, especially with large providers.
What is the Terraform state pull and push commands?
Terraform state pull downloads the current state from the configured backend and prints it as JSON to stdout. Terraform state push uploads a local state file to the configured remote backend. These commands provide low-level access to raw state content and are used in emergency situations, migration scenarios, or custom automation. State push overwrites the remote state lock-free, which is extremely dangerous without understanding the current state and lock status. These operations should be reserved for situations where the normal Terraform commands cannot solve the problem.
What is Terraform force unlock?
Terraform force unlock releases a stuck state lock when the process that acquired it has crashed or been terminated without releasing the lock. You provide the lock ID shown in the error message when trying to run a locked operation. Force unlock is a recovery operation and should only be used when you are certain no other Terraform process is running against the same state. Using it while another process is running could lead to state corruption. After force unlocking, verify the current state is consistent before running any Terraform operations.
What is the lock timeout flag in Terraform?
The lock timeout flag specifies how long Terraform should wait to acquire a state lock before failing. By default, Terraform fails immediately if the lock is held by another process. Setting lock timeout equals 10m causes Terraform to retry acquiring the lock for up to 10 minutes, waiting for the current holder to release it. This is useful in CI environments where multiple pipelines might try to run against the same workspace concurrently, allowing them to queue up rather than immediately failing. Combined with retry logic, it enables eventually consistent pipeline queuing.
What is the local exec provisioner in Terraform?
The local exec provisioner runs a shell command on the machine executing Terraform after a resource is created. Typical use cases include generating kube config files, triggering external automation systems, writing resource outputs to local files, or calling APIs that Terraform providers do not cover. The command is run in a shell and receives resource attributes through the self-attribute name syntax. The working dir and environment arguments customize the execution context. Because provisioners are not reflected in plans, they reduce predictability and should be replaced by purpose-built Terraform resources or provider resources whenever possible.
What is the remote exec provisioner in Terraform?
The remote exec provisioner runs commands on a newly created remote resource over SSH or WinRM after it is created. It is typically used to bootstrap software on new instances, running package installations, configuration management agents, or application deployments. The connection block within the resource or provisioner configures the SSH or WinRM connection details. Remote exec is considered a last resort as it requires network connectivity, credentials, and creates non-idempotent behavior. For most use cases, Cloud init, user data, or configuration management tools like Ansible are more appropriate.
What is the file provisioner in Terraform?
The file provisioner copies files or directories from the machine running Terraform to a newly created remote resource over SSH or WinRM. It is used to upload configuration files, scripts, or certificates to instances before running them. Like remote exec, it requires a configured connection block and has all the disadvantages of provisioners: non-idempotency, no plan visibility, and potential for partial failures. For production use cases, baking files into custom IMIs with Packer, or using cloud-native mechanisms like Systems Manager or S3 to distribute files is recommended over the file provisioner.
What is data source dependency in Terraform?
Data sources are reread during every Terraform plan and apply to ensure they return current values. A data source can also have dependencies on other resources, causing it to be deferred until those resources are applied. This is the case when the data source's query arguments reference a managed resource attribute that is not known until apply. By default, data sources are read during the planning phase, but those with unknown arguments are read during the apply phase after their dependencies are created. This enables patterns where you create a resource and immediately query additional data about it.
What is the external data source in Terraform?
The external data source allows you to run an arbitrary external program and use its JSON output as data source attributes in Terraform configuration. The external program receives a JSON object of query arguments on stdin and must return a JSON object on stdout. This is useful for integrating with systems that Terraform providers do not cover, such as querying internal databases, calling custom IPIs, or running complex scripts that derive configuration values. However, external data sources are not visible in plans and can introduce security risks if the external program is not trusted or validated.